Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome into the Computer America show. And yeah, welcome into the new show. It's we have a couple new effects and a couple new, of course, announcements, and we are very pleased with them. But for everyone out there, happy Monday. I hope all of you are having a great day so far. And yeah, we can help cheer it up just a little bit here with Computer America, keep you entertained when you're working out, when you're driving, what have you. Hey, happy to be there. So on today's show, I think we're just going to jump right into this. And on today's show, for anyone out there who has not read the show notes over on our website, we have, of course, the HSA Foundation. And we're going to get into exactly what they do. We have Dr. John Glossner here. He is the president. And we're going to explain what they do, why they do it, and how they are making your lives simpler, easier, and, something like this very, very needed in such a fragmented world that we live in. So let me bring him on. Once again, we have Dr. John Glossner, again, president of the HSA Foundation. So, John, thank you for joining us on Computer America, and welcome.
Thank you. Thank you very much for having me. Happy to be here to describe what the HSA Foundation is all about.
Yeah, no, this is a first. Not the first time like we had a standards organization here on the show. We just had HDMI about a month and a half ago. And it's always interesting to have the organizations behind standards, because you don't just work with one company and one set of technology. You work with all of your partners, and again, if you're watching the video portion, we're going to switch over here, and you work with a number of very, very large companies that people use every single day, and it can't be easy dealing with people who have so much invested in research and development and their own technologies, and then saying, hey, you have to play nice with all of these different ones. So before we get into your partners and what, and all that good stuff, why don't we start with a little bit of background into the HSA Foundation for anyone who may not have heard of them?
Right. So HSA stands for Heterogeneous System Architecture Foundation. And the goal of the foundation is really to focus on making it dramatically easier to use and program these new parallel heterogeneous computing devices, things that are kind of in the CPU plus era. And so we do that. It's a very hard problem, which is why there are so many companies involved. We do that with an open architecture, and we provide royalty-free access to all of the standards that we're creating. And in many cases, we provide open source tools for those on our website for the implementation of the specifications. So if we just step back and think, what is a heterogeneous system? Mm-hmm. Pretty much everything you have is a heterogeneous system. Whether you're thinking about your laptop computer, which has a central processing unit, CPU, and a graphics processing unit, GPU, that same type of system is now proliferating across every category of compute device, from supercomputers and data centers all the way down to our internet-connected refrigerator. And it's a very hard problem, which is why a lot of very important companies are members of this foundation. And so really solving how to program those systems so that they get the performance that an end user is desiring is the actual goal of the foundation.
Now, and that is obviously you have a lot of ground to kind of monitor and cover. When was this started? I mean, was it started back in when personal computers first became a thing, or is this the Internet of Things rose and HSA Foundation came up with standards? Like when did HSA Foundation start?
So we founded the organization in June of 2012, and the co-founders of the organization were AMD, ARM, Imagination, MediaTek, Qualcomm, Samsung. So as you point out, some very, very large semiconductor-related companies, both from building products and building IP and licensing them and things like that. So I think historically in that time, 2012, these systems were really just starting to appear, and pretty much over the last 5 years, that pace has accelerated to the point where now almost every system that's a computer system is somehow a heterogeneous system.
Hmm.
So I think it was at the beginning of that time these companies all realized, hey, this is a really hard problem. It's going to cost a lot of money to solve this on our own. And if we all have different solutions, that won't be very efficient for the industry in general. So let's form this foundation. Let's put our IP into this foundation so that we can get reuse of all of the stuff that we've developed. And then it's a mechanism for reducing the cost of that development and having a standardized way that all of these companies can integrate IP and have them work cooperatively together.
Yeah, no, it's something that we've seen before. I mean, 2012, a relatively new organization, been around for a few years. But we've seen this with other things such as IEEE or HDMI. I mean, having that one set of standard, I think companies can kind of get lost, and we started to see this with the Internet of Things, connected devices that we all have in our homes, and when it first started, there was no homogenization. There was just Zigbee, Z-Wave, Wi-Fi, blah blah blah, so many different standards, and you kind of run into that problem where everyone feels like they have the right solution, and as we've said before, if you end up with the right solution, it's like hitting the jackpot because then everyone pays you royalties and everyone does that. But, as we can take note from, like, again, IEEE, it's better, and you can speak to this, it's better that everyone is on the same page, right? Not just for the companies who get to, of course, utilize more components, between all these companies that you said, but also for the end consumer, right? Like it helps the person trying to use all this.
Yes, absolutely. So it goes all the way from the end user through the applications programmers, all the way down through the entire kind of software stack, that no matter what the application domain, and it benefits at every level of that ecosystem.
Perfect. And and before we get into, we're going to talk about some of these academic centers of excellence. As we said before, Dr. John Glossner, obviously, doctor. What is your background, and how did you get involved with the HSA Foundation?
So my background is in digital signal processing and building processors for wireless communications and signal processing. And those systems are also completely heterogeneous systems. And so as part of let's say, the last 15 years or so of building everything from GSM through LTE types of systems, we've noticed that in our own world, we were resolving the same types of problems over and over again. And how do you get these different types of processors to effectively communicate with each other? So even in that context of those embedded wireless systems, this problem domain is very relevant. And so from that experience, my company joined this foundation, and eventually, then contributed in domain signal processing, and eventually, now I'm helping to lead the organization as we move from a kind of a hardware focused centric more to an applications and software focused basis.
Makes perfect sense. Sounds like they got the right person for the job. So, like I said, why don't we get into the reason that you're here? Because partnering with all these different companies, and people can still become members of this organization. But yeah, there's something here about the academic centers of excellence, and how does higher education institution become one? Because it's one thing for these companies to have a standard, but it looks, again, just from reading this, it looks like you're trying to do some outreach to, the people training the engineers, training the manufacturers of tomorrow to work with the standard, right?
Absolutely. And so these centers of excellence are part of our academic partnership program. And we do reach out to key universities worldwide to develop relationships with them, particularly if we have an area that is not so much development, but maybe requires some type of invention. That's not something the foundation would typically maybe perhaps do on its own, but the foundation and its member companies will work with some of these universities to work on a solution to some particularly hard problem in the field of heterogeneous parallel processing.
No, yeah, no, that is perfect. And what are some of what colleges, or which colleges, I should say, have kind of earned the honors or joined the initiative and become centers of excellence?
Right. So yeah, so we have about four of them right now. And so maybe I'll just give a little bit of a background on why we chose them and kind of talk about each of them.
Sure.
So the first one was Northeastern University, the Computer Architecture Research Lab, led by David Cayley.
Mm-hmm.
And so you can imagine, like, if you're trying to figure out what the performance of just, let's say, your laptop computer is, where you only have, maybe perhaps one type of CPU in it, and you're still trying to figure out which is the best laptop for you to buy. Well, it turns out at Northeastern, they've been characterizing not just CPU performance, but heterogeneous performance. And so they have a set of algorithms that they've implemented in a benchmark suite called Heteromark that was developed in conjunction with the HSA Foundation that gives an idea of how a heterogeneous system performs compute processing. And so those algorithms are everything from machine learning to signal processing and security, and they keep continuing to add to that. And they're quite expert in evaluating heterogeneous systems for relative and comparative performance.
And just real quick. Oh, and just real quick. This performance mark. I mean, very, very interesting because a lot of what we do here on the show. I mean, we just with one of our correspondents just a couple weeks ago, we went out and built our own computers, and it's even for someone who embroils themselves in this kind of industry on a day-to-day basis, when I had to go out and build my own computer, or when I had to go out and look at other computers for other people, I mean, it was very, very hard. Like, because you can just go over benchmark after benchmark for every piece individually, but like when I put together a computer, I just have to look for which pieces have the best individual benchmarks for each one, and then just kind of assume that if they have good benchmarks, they're going to work well together because they're all well performing pieces. Is this markup that you kind of mentioned is this an initiative to kind of replace, each piece did this well, and now your HSA Foundation is going to have a single kind of number that people can point to and say, oh, look, this entire system got 91 out of 100 or 78 out of 100, even though the parts may test differently individually?
So yes, and that's actually an excellent point. And so Heteromark does put out an aggregated number that you can run on a number of different platforms, and you can use it on the same platform with different types of runtimes. So you can look at, for example, the performance of a language, let's say OpenCL, running on exactly the same heterogeneous system, and then compare it to, let's say, an HSA system running on the exact same heterogeneous platform. Or you can compare across two different platforms. And if you only care about, let's say, a certain type of benchmark, let's say machine learning,
Mm-hmm.
you can run a subset of the Heteromark benchmarking suite and determine how well any one particular platform might do on, let's say, just machine learning. So as you point out, it's incredibly complex to do it when you're looking at the same type of system. And so Northeastern had a lot of experience in doing these type of benchmarking systems. And so it was natural for us to work with them to look at how a heterogeneous performance benchmark might be implemented fairly.
Great. No, and and again, sorry for going on a little tangent, but we were talking about different universities, Northeastern University in Boston. And by the way, this seems like something that I think a lot of universities could really get behind. We just talked, or we talked with a couple months ago to a computer scientist. I forget his name, from Berkeley, and might mention this to him. But no, this is the kind of thing that I think a lot of universities who do a lot of research would totally jump aboard. And as I understand it, you mentioned worldwide you're getting some attraction, and you have two leading German universities also became academic centers of excellence. So, what are they working on? How did German universities kind of get involved, and what do they bring to the table?
So it's kind of an interesting story, but the community of, I'll call it heterogeneous architects, is actually not that large. And we tend to meet at the same types of conferences. And so for Friedrich Alexander University in Erlangen-Nuremberg, FAU, I happened to meet one of their researchers who had published a paper that was attempting to solve a particularly difficult problem that the foundation has. And so, we talked with them about their research group and the type of work they were doing. And so we ended up then, after a number of months of discussion and collaborating and interacting, we ended up working with the Department of Computer Science chair there, Professor Dietmar Fay. And so what they were doing is integrating image processing accelerators. So think of the things that are displaying 4K video on your laptop or something like that. They were doing that in FPGAs and developing HSA Foundation compliant interfaces for things that are running on an FPGA that would be also an accelerator, a valid accelerator in an overall entire HSA system. So very, very interesting extension of the frameworks that we've been working on, something that we had to kind of try and prototype out before we knew for sure it could go into a specification. And so they were leading that in conjunction with and in collaboration with TU Darmstadt, and their Professor Andreas Koch, who leads and chairs the Embedded System and Applications Group, specifically now focusing on reconfigurable computing on FPGAs within an HSA framework. And actually automatically assembling and generating high-performance multi-threaded compute accelerators on FPGAs dynamically and automatically that conform to an HSA system. So both of these were very, very interesting kind of activities that were going on, very complementary to each other. Some of which were, reconfigurable, others of which were image, signal processing. And so I'll call it a wider range of fixed function-like or reprogrammable-like reconfigurable compute accelerators now making their way into HSA systems, following all of the other protocols and being compatible with every other accelerator in a HSA system.
Right, and I just have to ask this question. You mentioned that obviously you meet a lot of people at the same conventions, and it's over and over again. How often do you kind of talk to people or talk to organizations and go, hey, we're working on this problem of making so and so work with so and so, or something play nicely with another, and then you just kind of have to shake your head and going, dude, we've been doing that for like 5 years. Like, come on over. We're working on the same thing. Like, is this a problem being tackled by, of course, the HSA Foundation, but do you find it, being taken on by individual universities at a smaller scale, or, are other people doing the same thing that the HSA Foundation is doing?
So there are some other approaches to doing this. They tend to come from large companies that have a large amount of resource to be able to put into the problem. And if I kind of think back historically, in the first, let's say, 2 years of the HSA Foundation, the real thing was about getting the hardware correct to be able to run a heterogeneous system architecture. And basically that means cache coherence and shared virtual memory. And I think pretty much every processor vendor is now or already has this type of hardware or is moving to it within, like a half a generation.
Mm-hmm.
But that was, I think, a nice contribution. We came out, we showed how it worked and why it works and how it reduces copies between all of these different types of accelerators. And that was the first 2 years. The next 2 years was really about getting the software right. And there are a lot more people working on the software aspects of heterogeneous systems. How do you design a runtime? How do you make them interoperate?
Right.
The HSA Foundation has a kind of advantage in that, all of the companies that contribute royalty free. So any solution that we come out with and standardize is available to anyone who joins the foundation, and all of the IP issues are resolved in that. So there are a lot of benefits to doing that, but there's always research going on into how to make heterogeneous programming better and easier. And so we naturally end up in a lot of those places. And sometimes we can usually, sometimes say, hey, well, this is how we solved it, and we've been doing that for a year or two. But we still do see very new, interesting techniques being proposed and implemented, and that's how technology progresses, and I think it's good for everyone.
No, absolutely. And yeah, speaking of, one of the ways that it progresses, of course, the hardware working together is one thing. You mentioned that end users can definitely benefit from this, and of course, all of their ilk. But you also mentioned applications and programmers and things like that. So why don't we talk real quick about how, your system can help, applications, programmers, of course, with Internet of Things. I mean, just from a software perspective, how are you getting involved, or how are people getting involved with the HSA Foundation?
Well, if you think about historically, if you wanted to program, let's say, a CPU, you got your favorite compiler and everything was fine. You had one view of the CPU and your program ran on the CPU, and that's all that you had to be concerned about. If you were going to program on a GPU, you had a completely different tool chain for doing that didn't know anything about what was running on the CPU. And if you move into the embedded world, the same thing happens if you're talking about DSPs or image signal processors. They all had their own tool chains. They didn't intercommunicate with each other. They had no common sense of how do you debug or profile one of these systems across all these different processors.
Mm-hmm.
And pretty much they required expert programmers to do all of that. So what HSA does is it abstracts away a lot of those complexities and puts everything within single source programming. By that I mean you have one source file, and it's written in the common language that you're comfortable with, let's say C++ or Python or OpenCL or C++ AMP, whatever your favorite language is. We don't try to say here is the best language, use it. We try to admit all the languages, and then with everything in the same file, to be able to then have a one system view of the entire heterogeneous system. So that really reduces the complexity on the application programmer and allows them to take advantage of any of the compute units that might be available within the system.
That is such a great approach. I mean, we of course have a monthly Linux show dedicated to open source. So loving what we're hearing, but also definitely enjoy the fact that you don't pigeonhole people into saying that if you want to use, if you want to use our open source, our standards, do C++ or do Python or do blah blah blah. By of course admitting all those, I mean programmers are fickle people. Like either their programs are fickle or the people are just strange. And choosing a programming language can be as simple as personal preference. Like it's sometimes it's not even logical. So it's very, very nice that you include so many different ones. And of course, that's going to help a lot of different, a lot of different systems. So, why don't we talk about, of course, things such as you have here vision-based Internet of Things systems to mobile devices, desktops, all of those. I mean, including AR and VR, which are still kind of barely making it into the consumer space and still need a lot of standardization. How are you helping with things that are just kind of cutting edge? Like, how are you finding maybe AR and VR are kind of advancing thanks to the HSA Foundation?
So one of the key issues is being able, in all of these systems, they have huge amount of compute inside of them, but you have to be able to get access, and you have to be able to do it in a way that the person programming, your favorite game engine or whatever, or your favorite neural network application can make easy access of them. And so the HSA Foundation assists with that by these open sets of standards in how you intercommunicate among all those different processors. Another thing is that's maybe not always as much brought up is that the reason that we have these different heterogeneous processors to begin with is because if you have a specialized type of compute, let's pick neural networks. If you try to, let's say, train a neural network on a CPU, you can maybe take days or even months. And a specialized processor will greatly accelerate that, and it tends to do it at much, much lower power as well because it's specifically designed for executing that task. So in the case of the Internet of Things, where you have probably a battery-powered little device connected to some sensor
Right.
that turns on once a second to get its information, this low power aspect is very important. So everything from these very, very tiny embedded devices all the way up through servers have effectively the same thing. Get access to the performance and reduce the power of the computing in that performance.
Great. And what would you say to maybe people who are, of course, standing on the outside? Like we've been saying, you have a lot of, you have a lot of great partners, and obviously these dozen or so, or I'm sure you can mention the exact number of partners you have, but it's not all of them. What could you say to maybe those who are standing on the outside, going, well, I don't feel like being compliant with them or buying into their ecosystem. I mean, how does HSA make life easier for system designers and for, other people designing things?
So we have 40 member companies and 30 universities who are members. We're all focused on the same thing of making these heterogeneous systems easier to program. And we're all solving the same basic problem. And if you're a commercial company, I would invite you to consider the fact that everyone who is a member of the organization, anytime they contribute intellectual property, that intellectual property is available royalty-free to all of the members. And so that's an important consideration. And then it depends on where you are in the ecosystem. So if you're like an IP provider, we have a multi-vendor API, which tells you how to take, let's say, an ARM CPU and an Imagination GPU and maybe someone else's DSP or image signal processor, and gives you an architected way of integrating them into the same system and allowing them all to be compatible within that same system. And if you were to go do that on your own, you would have to get all of the different vendors to adhere to whatever other standard you decide to come up with anyway. Or if you created your own, that's going to be a quite challenging aspect of trying to get all of those interfaces correct. So we reduce away all of that complexity with the large number of vendors already in the foundation. They can all intermix their parts, and that goes a long way to reducing then the complexity of building these heterogeneous systems. And then, of course, the other stuff is about programming them. So, but you can build them, you can program them, and they have benefits. And so membership is open to all. Anyone can join. And so we actively encourage and invite companies to become members of the foundation and help solve this problem.
No, that sounds great. And hey, the music means we have to take a break. And Dr. John Glossner, if you could just stay over for a couple minutes, we'll wrap this up. And yeah, we'll wrap this up. So for everyone out there just joining us, well, commercial break. But yeah, we have Dr. John Glossner, president of the HSA Foundation. And yeah, we'll be right back and with a few more minutes of course, talking about the HSA Foundation. Be right back.
We are all Brother Wolf. 10 years ago, a group of locals banded together to create positive change. We took animals into our homes, held adoption events at local retailers, and talked to the community about our mission to help build a no-kill Asheville. A decade later, we have achieved so many victories for animals in need. There's been so much progress, yet there's still so much to do. As part of our year-long celebration, we encourage you to become a member of our special Compassionate Circle program. With a monthly donation of $10 or more, you will have behind-the-scenes access to the work we are doing at Brother Wolf. Our goal is to reach 1,000 members because we receive no government funding. Working together, we can help build and sustain no-kill communities. Learn more at compassionatecircle.bwarf.org. We are a 501c3 tax-deductible organization.
And welcome back to the Computer America Show. It is 31 minutes past the hour as we come back to, once again, Dr. John Glossner, and he is the president of the HSA Foundation, talking for the last half hour about how harmonizing such a complex industry is going to help not just end consumers, but of course people working with these systems, and of course people making these systems. So, John, thank you for forcing me, for letting me force you to stay over for a couple minutes. But to wrap up this interview, I mean, can we expect any significant development for the foundation members this year? Because obviously an organization such as yourself, you don't want to just rest on your laurels. It's extremely a, stay up to date, keep innovating kind of proposition.
So yeah, and so we continuously innovate and work on problems. So this year we will release the 1.2 version of the specifications that will provide support for even more types of processors, these fixed function accelerators and FPGAs that I had previously mentioned. Mm-hmm. We'll have more validated and robust memory models so that more activities can take place in parallel within these systems. So a lot of things out of the infrastructure. And also I would like to maybe comment as a significant, maybe practical implementation. Sure. We have had a lot of interest recently from China, and we established a China Regional Committee, and that committee is meeting to actively determine how to incorporate and use and adapt and adopt HSA Foundation systems for use across a much broader worldwide market. Of course, we already have member companies from all over the world, including China, but we're always interested in joining with standards efforts to help in the same type of system problems.
No, that's great because, technology, of course, a lot of it comes out of, Asia, China, and, Asia Pacific. There's a lot of, especially your field, processors are, of course, made over there. And I can see where, it's that thing where no one piece of technology is really ever made in one country, and it's not really even sold in one country. I mean, it really is a worldwide problem that you're trying to solve here. So add on to the complexity of many different companies and many different missions, many different goals. Add on to that, why not, many different languages on top of that. It's, you face a very tough problem, but at the same time, it sounds like, you have a lot of support from a lot of, very, very important people. And I think you guys are hot on the trail of, not, making sure everything works together. So let's say, let's do a call to action to our audience. If they want to learn more, or maybe for, businesses, individuals, if they want to get involved, like, is there any way for individuals to get involved, or if companies want to get involved, where do they go? What do they do? What can they do?
So the best place is to check out hsafoundation.com. On our website, we list the types of activities we do. Membership is open to everyone. We have various levels of membership, from associate to contributor and academic, all the way up through board member. And we encourage participation. You're welcome to send to the info at the website, and we will be more than happy to discuss with how you can come along and work with us to develop the standards for heterogeneous computing for the future.
That sounds great. And John, unless we miss anything, I think that we're just about to wrap this up. So, last comments, and of course, hsafoundation.com, as you mentioned, we have a link in the show notes right there on our homepage at computeramerica.com. And yeah, John, unless there's anything else, great interview. Thank you so much for being on.
Thank you so much for having me and for giving out the word of the Heterogeneous HSA Foundation.
My pleasure. And, please, next time you guys have a conference or, announce something new, feel free to come on back to Computer America. Love to have you back on.
Thanks. We'll be more than happy to call in again. Thanks.
Sure. Perfect. All right. And everyone, once again, that is Dr. John Glossner, president of the HSA Foundation. Once again, check them out, hsafoundation.com. So with that being said, John, thank you so much. Have a good day. Bye-bye.
Thank you.
All right. And there he goes. Once again, HSA Foundation, you can check that out, computeramerica.com. If you are just joining us for any reason and you missed that entire interview, a lot of acronyms, a lot of words thrown out, but I think we got through it, and most of it understandable, a lot of it understandable. It was a lot of fun. If you missed any of that, feel free to go back to computeramerica.com and check out the archive where you can listen to the interview again, or you can listen to any parts that you missed, again, right there on our website. So with that being said, why don't we jump into computer and technology news? Because, we have a few different, we have a few different stories that we can, of course, talk about. A lot going on in technology, and as always, we try to avoid technology in politics. We'll try our best, but unfortunately, those dang pesky politics keep butting their head into technology. So, with that being said, why don't we jump into computer and technology news? So, here we go. All right, and once again, computer and technology news is brought to you by Computer America, and I think we're going to do this one. And and by this one, I mean, no, not that one. Here we go. Let's do this one. This one is very, very cool. This is coming from a publication called, of course, Motherboard. I believe they are, they are a publication of Vice. Very, very nice news organization. And I definitely like this one. So, and by the way, for anyone out there, watch the video portion and you can read along and see the articles, videos, what have you, as we do them. But this is by Michael Byrne, again from Motherboard. And check this out. This is another example of artificial intelligence. Yes, not real intelligence. That's very, very hard to find. But we can make intelligence. Artificial intelligence algorithm beats even the world's worst traffic. My goodness. So they're saying that only 10% of cars would have to be connected for it to work. This is very exciting. One of the ever so popular promises of what connected cars and Internet of Things has to promise for a lot of industries. So check this out. They're saying that, again, only 10% of cars would have to be connected for it to work, saying the height of individual versus collective irrationality has to be automobile traffic. Very, very complicated. I mean, roadways were built around the assumption that we as individual human actors will behave in ways that appear to reward those behaviors at the level of individuals but wind up harming the collective group. So, you can, of course, notice this when maybe one person makes a greedy merger, goes into the wrong lane, cuts someone off, just, again, not really thinking of the flow of traffic as a whole. But, this can, of course, cause many people to hit the brakes or even cause accidents. It's not the best way. But fixing this is among the promises of driverless cars, where if we can push humans and their tendencies out of the loop, because again, artificial intelligence has a very clear and set rule. They have, if this happens, if that happens, in perfect conditions, do this. In non-perfect conditions, assume this, this, and this. I mean, computers are not irrational. They're trained to work a certain way. So how does that help kind of cars? Because humans are very irrational. We work with imperfect information. We work with the assumption that no one is in our blind spot. We work with the assumption that traffic is flowing at a normal pace, a quarter mile ahead that we can't see. We work with all this, and it has led to some problems. So the promise of artificial intelligence in cars means less congestion, less pollution, fewer accidents, less roads. Yes, less roads. Not having to expand the roads that we already have, but making use of the ones that we currently have more efficiently. That's right. No more of those stupid construction projects with orange cone after orange cone after orange cone for miles. Have you driven through Georgia? Have you driven through South Carolina? My goodness, there are more orange cones in that state than there are people. My goodness. That is a future I can get behind. But of course, and they also say that this could mean less time spent driving. Promise of AI. Of course, that's the pitch, but as the article says, but the actual system remains largely future tense, even as driverless cars ease into the present. Although, ease into the present is a very generous way to say they're working on it. Because if anyone has been paying attention to the news, for the past couple days, I believe there was that article about, at least I saw it on the television, but there was that incident where an Uber self-driving vehicle kind of, sort of, maybe a little bit flipped itself while it was self-driving. Of course, the passenger, there was no driver, but the passenger was okay. But yeah, artificial intelligence driving should not flip itself. So, yep, there's a lot of work to be done, and as the author says, ease into the present. But they're saying that to this end, computer scientists at the Nanyang Technological University in Singapore have developed a new intelligent routing algorithm that attempts to minimize the occurrence of spontaneous traffic jams throughout a roadway network. Very important. And, they of course have published their work, but they're saying that route finding is of course a natural branch of computer science, where efficiency loves, route finding. If you can find the most efficient route, you of course spend less power, and it works for very, very complex things. And let's face it, if you've ever driven in Los Angeles traffic, there is no thing in this universe as complex as rush hour traffic on the highway in Los Angeles. Perfect fit. So of course, they say that the researchers' algorithm starts off by just assuming that given enough traffic density, stuff is going to happen. That's not the word used in the article, but yeah, stuff is going to happen. And that something is going to cause enough of a traffic change to result in a network breakdown. But the goal of the algorithm is to maximize, the efficiency and reduce the whole messy part of it. And they're saying that, of course, crunch some linear algebra and we wind up with optimal routes throughout a network. And that is, again, after many artificial intelligence, run simulations. And they're saying that, of course, we come up with some mathematical optimizations that make this kind of calculation feasible in real time. And with that being said, they can use, more data that we can put into the system. The better the outcome, the better the data that comes out is going to be. The more fleshed out, the more realistic it's going to be. And again, they're saying that with just 10% of the cars in a network talking to each other taking into account one another and of course all the cars around them, we can severely reduce the occurrence of traffic breakdowns, of complete traffic standstills. We can reduce the amount of standstill traffic by a bunch. They're saying that, of course, as it turns out, only 10% of cars in a network need to be driving according to optimizations for those optimizations to have a positive effect on the entire network. So, of course, you're free to continue driving like an unoptimized, can't say that word either. But yeah, I mean, this is very, very cool because we were wondering what happens when self-driving cars get here. I mean, I think a lot of people are going to want them. It's going to offer a lot of promise, but at the same time, what about people who don't want to drive, who want to drive, who don't want an artificial intelligence to drive for them? And as it turns out, there's a lot of benefit to completely banning people from driving. There's a lot of benefit. There's more benefit than just 10%. But we start to see real change, real positive change when 10% of the cars on the road are self-driving. So that means that we can have people on the road, we can have them drive side by side with artificial intelligence cars, and that won't mean the end of the world. In fact, it will still be good. It will still be very, very efficient. People can still drive their cars, and AI can coexist alongside them. This is good news. I mean, 30, 40 years, we'll see what happens, but in the immediate future, in the next 10, 15 years, this could mean that even if you are driving around like a Neanderthal, if you're driving a car like, a troglodyte, it's okay because those driving conditions are still going to be better. Even if you are not driving in an artificial intelligence car, driving conditions are going to be better in general. So, very cool article. And again, this coming from Motherboard. Check it out. There's a link in the show notes over on our website. So, with that being said, why don't we get into... Okay, yeah. How about we do this one? This is very, very strange, although I'm going to call it strange, but at the same time, it's not really, because I grew up with this thing called Happy Tree Friends. And right off the bat, I think a lot of people know this if they have heard of the series. Do not show to children. It is deceptively cutesy. It is not exactly for, audiences probably under 16, 18 years old. Of course, introduced way younger, and it had an effect. It had quite an effect. But at the same time, I think this is following in the same vein. So this is through YouTube, and this is a finding by BBC. So the BBC News, this coming again from BBC, and how, get this, the disturbing YouTube videos that are tricking children. And yeah, tricking children. That's not exactly what you want to do. And we'll see if YouTube has some kind of answer for this, because right now they don't. I mean, a lot of user videos, YouTube does not, beyond a basic set of, agreed upon morals and standards, think, no death, no gore, no extreme violence, no acts of terrorism, certain things that I think across a wide swath of people, they'll say, oh yeah, that has no place on, being on a child-friendly site, or at least a site accessible by a majority of the population. They don't have an age ranking system. You can put, contains explicit content, but that's user generated and user determined. Unless it breaks one of those very, very extreme rules, there's no rating system on YouTube. There's nothing to say if something is suitable for a 7-year-old, if something is suitable for a 14-year-old, a 21-year-old, whatever it may be. There's no rating system. So you lead to situations like this, where if you're not paying attention, it might look like an ordinary video featuring Peppa Pig. That's right, the cartoon character. But soon after pressing play on this particular YouTube clip, the plot turns dark, where a dentist appears with a huge syringe, and of course, there's a series of probably not standard dental procedure happening. Not good. So, parent and journalist Laura June almost immediately noticed something was not quite right, as her 3-year-old daughter was watching it, saying that Peppa does a lot of screaming and crying, and the dentist is a bit sadistic, which is, again, for a 3-year-old, a little inappropriate. So, but the animation is close enough to look like the character. It's crude, but close enough that the daughter was like, this is the cartoon that I normally watch. Which I get. I mean, very easy to emulate what you see on television. So, it's far from an isolated case, and this is what BBC Report has found. They have found hundreds of similar videos of cartoon characters with inappropriate themes. It's a very common practice to take something that you see on television, of course, has name brand recognition, has household recognition, and then put your spin on it. And not just put your spin on it, but do so in a satirical way, do so in a, not so appropriate way, taking something that is meant for all ages and turning it into something that is inappropriate has its own kind of attraction to these content creators and to really, a certain audience. So that's why you get, things such as Peppa Pig, and of course you get things like characters from the movie Frozen, or Minions, or, Thomas the Tank Engine, many, many different characters. It's something that I think a lot of people kind of share in common, and then when you put a twist on it, you reach that same number of people, rather than making your own characters. So, of course, some of the videos are parodies or have such over-the-top content that they're clearly meant for mature audiences. That's for sure. While others are unauthorized copies of authentic cartoons or use the characters in innocent ways, troubling to copyright lawyers perhaps, but not necessarily harmful to children. So with that being said, they're saying that many, like the video that she showed her daughter, contain both disturbing content and could pass for real cartoons, which is a problem because obviously YouTube is meant to, be for all audiences. So they're saying that, they say that they contacted 2 different companies who do this, and they're saying that should parents take more care when it comes to allowing their children to watch cartoons on YouTube. And they're saying that it's perfectly legitimate. This is a quote from the London School of Economics and a professor in social psychology, saying that it's perfectly legitimate for a parent to believe that something called Peppa Pig is going to be that character. And they think that many of them have come to trust YouTube as a way of entertaining your child for 10 minutes while the parent makes a phone call. And I think and I think if it wants to be a trusted brand, then parents should know that protection is in place. Again, very hard thing to do because YouTube has no innate rating system. Something looks like something, you assume it is, and then next thing you know, it most certainly is not. So by that being said, they're saying that flag videos are, of course, manually reviewed 24/7, and any video that does not belong in the app are removed within hours. This is, of course, a statement from YouTube. And for parents who want a more restricted experience, we recommend that they turn off the search feature in the app. So you just, so you go find the video that you want, and they can't search for anything else, that isn't related to the original video. So the company also suggests that parents use the YouTube Kids app, which is available for mobile phones, and turn on restricted mode, which limits flagged content. It can be found at the bottom of the page on the YouTube site, and the cautions that no filter is 100% accurate. So they try with a step further with, again, the YouTube Kids app, and, you can have restricted mode, but even that, they say, can and probably will slip up from time and time. It's one of those things that, parents have trusted video game ratings, they have changed over the years, but, video games are no longer just video games. There are video games for adults, as we know, NC-17 or mature, things that would not be suitable for a 12 or 13-year-old. Whereas we have, things rated, T for teen or, E for everybody for video games or for television. You have, of course, Y7 or, PG-13. These rating systems, I think a lot of parents kind of grew to expect that any media that they consume, any content that they can give to their kids is going to be vetted in this way. But when you have a user-generated ecosystem such as YouTube, where it can contain anything, there's moderation, but not to the extent that YouTube is. I mean, they do a lot of great stuff with artificial intelligence, with automatically detecting certain things on YouTube. But at the same time, there are hours and hours and years of footage being uploaded to YouTube every single day, every single week. It is impossible to go through all of it. So, YouTube's basic answer to this is, hey, take a vested interest into what your children are watching. Take an interest into what media your kids are viewing, because, as they said on YouTube, one thing can look like something completely different. And again, I brought up a TV series that's, even though first appearances may have it set to one thing, there's definitely an audience for turning something cutesy and banal into something that is, oh my goodness, just way dark and way shocking. And hey, that shock value has value in itself. So at any rate, this was, again, from BBC Trending. You can check it out. We will have a link in the show notes. So we have time for just one more story. We'll see what we can get into. But yeah, it's a lot of great articles today. And I think for our last one, we're going to do this one. And we offhandedly mentioned it just a little bit ago. And yeah, I figure, hey, why not get into it for real? So this by John Fingus. This is Engadget. And yeah, Uber. You may know them. Just talked about their self-driving car flipping over. And of course, speaking of that, Uber resumes its self-driving car test following the crash. And I said this at home in the privacy of my home. I didn't have anything to back it up. But at least Waymo, Google's self-driving car project, at least, Mercedes self-driving car project, or, Tesla self-driving car project. Well, I can't really say that about Tesla because, well, actually I can. Because Tesla says that if you activate self-driving car mode, you have to be vigilant. You have to check, you have to touch the steering wheel once every minute. It's going to drive for you, but you have to be actively monitoring it. Whereas Uber, they're even though the Tesla crashed, unfortunately killing its driver, there's something very different about someone sitting in the passenger seat and the Uber car ending up like a turtle on its back. Something very different. So once again, Uber's freeze on self-driving car tests following the Arizona crash was short-lived, saying that they have confirmed to Engadget that they have resumed their development operations in San Francisco as of this morning. So the Arizona and Pittsburgh cars are still idle as of this writing, but they're expected to go back into service soon as well. And the company hasn't said exactly why it's resuming so quickly, and they've reached out for of course, comment. However, the initial reports surrounding the crash suggest that there wasn't much Uber could have done, saying that the Volvo XC90 was knocked on its side after another driver failed to yield. Oh, very cool. So it wasn't even their fault. And that autonomous vehicles are certainly supposed to react to human drivers, but there's no guarantee that they can always respond to someone ignoring the rules. So yeah, we're going to wrap that up there. We're going to leave that there. And everyone, I want to thank you so much for listening to the Computer America Show. Check us out, computeramerica.com, for everything that we've done here today. And be sure to tune in tomorrow, same time, same place. So with that, I'm going to leave it there. And again, check out computeramerica.com, 4 p.m. to 5 p.m. And until then, everyone, have a good day. Bye-bye.